Hey Max,
Hey Kylo, what's up?
can you teach me how to multiply and simplify fractions?
Yes, but only if you promise to use this information for good and not for blowing up planets.
Yes.
Okay then. Alright, so how do we multiply fractions together? Multiplication is usually learned after addition when we are in elementary school and learning how to add and subtract and multiply numbers. Multiplying and dividing is usually taught before addition and subtraction because it's actually easier to multiply fractions than it is to add and subtract them. And so the reason why is if you had a fraction a divided by b, remember b can be anything except 0, and you multiply that by c over d, you do what you want to do. You multiply the tops together, a times c, you multiply their denominators together, b times d, and then you're done. Right? Now there's a little bit more to it in simplification, but the nice thing about multiplying fractions is you just go across the top, you go across the bottom, the denominator, and then you're done. So let's look at an example. Let's look at 1/2 times 3 over 8. All right? It is just that simple. You do 1 times 3, which is 3. You do 2 times 8, which is 16, and you are done. All right? No need for common denominators or least common multiples or anything like that. You just go ahead and multiply their tops and bottoms together, and then you're done. Okay? Let's look at another example. Let's look at 2 over 9 times 18 over 10. Now I want to spend a little bit of time with this rather than just doing it. I want to do it 3 different ways. All right, let's just do what Max just told us to do. Multiply the top together, right? So that's the numerator. 2 times 18 is 36. 9 times 10 is 90. Now that is the answer, but we want to simplify this fraction, all right? So I made a video specifically about simplifying fractions earlier, and that should be available on the old YouTube channel there. But if I look at this thing, I go, all right, well, do these have any common factors? And they actually do. That's 9 times 4 divided by 9 times 10. All right. Remember, something divided by itself is 1, so 9 divided by 9 is 1. Multiplying 4 over 10 by 1 doesn't do anything, and so those cancel, leaving me with 4 over 10. And 4 over 10. These numbers both have a factor of 2 in common, so that's 2 times 4. Oh, no, it's not. It's 2 times 2 divided by 2 times 5. These 2's cancel, and I don't get 5 on top. This is why you do math in pencil, everybody. You get 2 over 5. All right, so that's the answer, 2/5. Is there an easier way to get this? Is there a different way to get this? Yes, there is. So that's, I'll call it method number 1. Just straight up multiplying the numerators, multiplying the denominators, and then after the fact, canceling things out. The problem with that is when you just multiply across, you could get very big numbers on the top and bottom. I'd like to prevent having to work with big numbers if I can. And so I'm going to cancel right off the bat. All right? Because this 2 is going to be on top and this 10 is going to be on bottom. And I know that each of these has a factor of 2 in common. All right? So if I pull out a 2 from 2, I'm left with 1. If I pull out a 2 from 10, I am left with a 5. So I'm simplifying things to begin with already. All right? 18 and 9 both have a factor of 9 in common. And so 9 goes into 18 twice, 9 goes into 9 once. And so what I have is 1 over 1 times 2 over 5. And it doesn't get much simpler than that. I get 2 over 5. All right? So I like this way of doing it because I get to cancel things out before I multiply them. I'm making my multiplication simpler in that sense. Okay? And that's really going to become important when I do a problem like this, where I have, let's say, 10 over 7 multiplied by 21 over 60. All right? Is it impossible to multiply 10 and 21 7 times 60? No, it is not. All right? But why make things harder for yourself? Because, I mean, what you get is 210 on top. I believe you get 420 on the bottom. And you got to cancel things out, and you got to think about what factors they have in common, those big numbers in the hundreds. Why do that to yourselves, right? 10 goes into both 10 and 60. It goes into 10 once, and it goes into 60 6 times. And across here, 21 over 7, that's 3, because 7 goes into 7 once. 7 goes into 21 3 times. All right, so I get 1 over 1 times 3 over 6. Now I could even handle this fraction right here, right, if I wanted to. Now I could just multiply 1 times 3 is 3, 1 times 6 is 6, and get 3 over 6. But I could also just notice that both the 3 on top and the 6 on bottom, whether it's right on top of one another or diagonally like we've been doing, they both have a factor of 3 in common. So I can pull out that 3. 3 goes into 3 once, 3 goes into 6 twice, and so I get 1 times 1 on top, I get 1 times 2 on the bottom, and this whole thing simplifies to give me 1/2. All right, and that's basically it as far as multiplying fractions goes. All right, the order that you do this cancellation really doesn't matter. You need to do it at some point if you are simplifying your answers. All right, we don't want to deal with 36 over 90, but we could deal with 2 over 5, which is easier. So that's basically it for multiplying and simplifying fractions. I recommend doing your canceling and your simplification first, all right? And then going ahead and multiplying across the numerators, multiplying across the denominators to get a simplified answer. But even if you didn't, the answer that you do get could still be simplified by canceling factors from the top and bottom. As usual, I'm going to end this video with some practice problems. And so here are 4 problems for you to try to make sure that you get the practice and get the hang of this stuff. Answers to these problems are in the description below. If you've learned anything, if you've enjoyed this video, please hit subscribe. Please like this video, share it with your friends. Keep coming back because I'm going to keep posting more mathematical content on all levels, across all disciplines of mathematics. And check back often, keep on mathing, and we'll see you next time.